Welcome to General Meeting 15. Please sign in at acmuc.org/c while I talk. Happening around EECS this week and next week. So our next meeting for ACM will be 2 weeks from now. Topic is TBD, and there will be free food. ACMW is having a meeting on this coming Monday. It's going to be a senior design overview. So you'll hear some things about like what senior design is, all those details. And then some senior design teams that are currently doing senior design will show off their posters and projects. So be sure to check that one out. An email should be in your inbox if you're on their listserv. ACM at Cat Hacks. This is coming up. This is a hackathon coming up this weekend. You can learn more on their website. This URL right here, I'm not going to say it. It's a hackathon at U of K in Lexington, Kentucky. And it is a MLH member event. Just like Revolution UC is. You can register and find the schedule, everything like that at Cat Hacks. Is the registration still open? Does anybody know? Okay. Who here is signed up for Cat Hacks at UK? Cool. Okay, so if you are planning to go to Cat Hacks, make sure you are signed up, and then you can join the Cat Hacks 2019 channel in Slack. So we'll set up carpool and everything for that. If you do have any questions, just ask it in that channel or ask Maddie on Slack, and we'll get you sorted. It'll be really fun to have everyone carpool down to that hackathon. Blockchain business. Now this is interesting, I guess. There's a new economics course being offered in the business college this coming fall. We were notified about it. It's called Blockchain in Business. So you can read about it there. Apparently they're going to talk about Bitcoin, blockchain, cryptocurrencies, but relating to business, not necessarily technically. But the professor offering it was excited about it and wanted to share it with us. Also, there is a prerequisite for this course, Econ 101, whatever it's called. But the professor said, if you want to take the course and you don't have that prerequisite, then it doesn't matter. They'll waive the prerequisite for you if you're interested in taking the course. I posted a PDF that's like 10 pages long with the syllabus and everything you need to know about the course. If you're interested in seeing what specifically is going to be covered. All the textbooks are free, by the way, for that course, so that's pretty cool. So be sure to check that out if you're interested. C++ review sessions, they're back. Alex is going to be organizing some review sessions for C++. So everyone here is like in CS1, data structures, algorithms, whatever. You've touched C++, right? So this will be a really good chance to brush up on your C++ skills. We started these a couple years ago, but then we stopped doing them, but we're going to start them up again now. The days for this are going to be announced. They're going to be on off weeks from ACM, so we don't overlap there. Before we go on, is there anything in particular, any like concepts or like C++ stuff that you guys want to like see covered in those specifically? Maybe like file I/O or like queues or like, I don't know, whatever you want. Anything specific? No? All right, that's fine. Yeah, but you'll get an email about that. These are really popular for people to brush up like before doing their homework or before an exam, something like that. Office hours are back. Mondays 1:30 to 2:30 and Thursdays 2 to 3. More resources are on the website acmuc.org. Fill out attendance so you can vote in elections, which I'll talk about later. Slack, sign up for Slack. You all know this, right? I hope. Conduct, look at the code of conduct if you want to. Yes. Elections are coming up Wednesday, April 25th. We'll have nominations the 2 weeks before, so the meeting before. You can nominate yourself or someone else. I'll send out more detailed information in an email if you're interested. We have 5 elected positions and 3 appointed positions. So the 3 appointed are appointed by the 5 people that get elected. So if you're interested in running for one of those positions, you can definitely talk to me afterwards or someone else. If you're an exec, raise your hand. Talk to one of those people. They can tell you like what it's like to be an exec, stuff like that. Honestly, it's pretty fun. It's a lot of responsibility, particularly with the hackathon. But I encourage you all, especially you younger members, to try out nominating yourself or someone else and running for a position. It's really fun. Cool. So now we're on to the main content. Kristian Snyder, Big round of applause. We'll be giving a lightning talk on many different programming languages.
Alrighty, let's get started then. So, hi everybody. Today we're going to be doing some lightning talks from me about different programming languages. So I titled this whole thing Lightning Languages. Here's some of the things that we're going to cover today. We're going to cover things like syntax, things like unique features of different languages, the type systems involved, and when to use them. There's also some things that we're not going to cover. Things like structuring projects, because that's a talk in and of itself, and I'm not interested. It's a disaster. We're also not going to talk about standard libraries. Those are gigantic, and they're usually very specific to the language involved. So again, I'm going to ignore them. We're also not going to talk about package management, which is another disaster. You can see that these are all disasters that you don't want to get into right now. Package management is very different among different languages and is mostly determined by whatever decision the language designers made at the time. Or, in another case, just kind of what evolved in the case of NPM. And then finally, we're not going to talk about which languages are best. I like all of these languages. They're all good for different things. And I do have ones that I'll prefer for certain cases, but I've used all of them. So, a little bit about me. My name is Kristian Snyder. I'm currently the Vice President of ACM UC. You can find me on the web at crouton.io. I'm at Kristian on Slack, and I'm at Snyder Chaos on GitHub. So, to start, we're going to do a couple of ground definitions. So, first is imperative. So what does imperative mean? Imperative is a type of programming language that uses statements that change a program's state. All of the languages we're going to talk about today, except for one, which we'll get to, are all imperative. Imperative meaning, let's say you create a variable. That variable is called x. You assign that variable a value of 1. X is now 1. Then on the next line, you add 1 to x. You've changed the state of x. That's the whole idea of an imperative programming language. It makes a lot of sense, which is why all of the languages that we're going to be talking about today are imperative. They are the most popular programming languages. And then, because it's important and because I know that it's complicated, typing. So, static typing and dynamic typing. Static typing means that types are determined at compile time. Dynamic typing means that types are determined at runtime. It's not really the most important thing to think about, except for the fact that static typing means that the programming language can tell you if there's a problem before you even run your program, whereas in things like Python, you usually get something like a type error, when you've done something wrong and you've assigned something to the wrong type, or you've passed the wrong parameter to a function, and you just kind of have to deal with it, and your program crashes. There's advantages to both, there's disadvantages to both. All right. So those are a couple of ground definitions, and now we're going to get started on the first of our 6 languages, which is probably the one that most of you know best right now, C++. So, C++ was created in 1985 by Bjarne Stroustrup at Bell Labs. Bell Labs as in the Ma Bell Labs, as in AT&T. So, we're going way back to the 80s on this one. And C++ was actually created, you may think it's like, oh, it's a superset of C, right? Not exactly, but it was intended to be. It was created as C with classes. Literally that simple. The whole idea was that Stroustrup wanted to make program organization easier while preserving the blazing speed of C. C was, at that time, essentially the fastest programming language, still largely in a lot of cases is. And he wanted to make sure that everything could stay very fast while making it a little easier to organize programs. If you've worked in a large C program, you know that it can be a disaster to have to organize all of your functions, all of your different modules and everything. So the whole idea was that this would make that easier. C++ has also been made famous by its absolutely massive standard library. This thing is gigantic. And there's a philosophy involved in here. A lot of these languages have their own philosophy. The primary one was to be a better C. Really that simple. C is good, make it better. The next one was to support object-oriented programming, so things like classes, structs, etc. We'll get into that. The next one was to support generic programming. Templating actually came a lot later in C++'s life than people realize, but it was a tentpole feature, I guess. And then finally, to allow data abstraction. One of the actual primary tenets was that he wanted to allow people to define their own types, and they would have to be just as fast as the C types, because people wouldn't use them otherwise, and so half of the language would be useless. So let's start with some syntax, and at this point, you're going to start seeing code on screen. I'm going to go through it, but it is going to be there. So let's talk a little bit about what this is. Probably looks familiar to a lot of people. So every language, or every program in C++ starts with a main function. So very simple. You just declare this function and the program knows to start here. We're going to create a string. We're going to print that string, and then at that point we're just done here. It's really that simple. But you may notice something here that I think a lot of people get tripped up on early on. You notice this standard colon. So a lot of people, when they start at C++, never see that because they see something at the top called using namespace standard. That is one of the things that I personally think screws a lot of people over when they're getting started in C++ in their first job, because that's a really bad, dark pattern that a ton of people then run into when they start like declaring strings, and then their code has type errors all over the place and they can't compile anything. So, very simple. This is just to kind of get you the feel of how it looks. We declare variables, we do things to those variables, and then we return things. Looks a lot like what you'd probably expect a programming language to look. Now we're going to get into a couple of unique features. I say unique because C++ is so fundamental that a lot of the features that you may think it has or that you think aren't unique, actually were first, and it just kind of got used by everything else. So the first one is namespaces. Namespaces are interesting because what they allow you to do is have different libraries that can avoid name conflicts. Now used, of course, very heavily by Java and C#. Those are things that you've seen if you've used them, but they're very important because what it allows you to do is, like, we're going to declare this namespace first, and then a namespace inside of it that has a function. We have another namespace. It defines a function with the same name that does the exact same thing. So how can we use them in the same way? We're going to start with first, so that declares that we're going to use that namespace. Then we're going to do inside first, declares we're going to use that namespace. We're going to be inside here, and then we're going to call that function. And to avoid name conflict, we're going to do the exact same thing with second. So this was massive. Like, it's hard to understate that this helped an enormous amount, because suddenly you didn't have to go trawling through all the libraries you were using to look for name conflicts and to make sure that you didn't name things the same thing as like the standard library did, which happened. So next, probably the one thing that I'm dreading having in here is pointers. So pointers are, you think, they're not unique. They're not unique at all. Every language has pointers, but not really. Like, if you look at the top, what is it? I went through like the top 10 languages from the Stack Overflow Developer Survey. I think the only two with pointers are C++ and C. The only ones that directly allow you to screw around with memory are those two. Nothing has pointers anymore. But it's very important to go over, because even though you can't manually screw with memory, it's still very important to talk about. So pointers reference memory. Memory may be on the stack, maybe on the heap. Not really important to go into what those are yet. But the whole idea is that we've declared a variable here. We've declared the variable x. Now we're going to create a pointer here and we're going to store the address of x in that pointer. The address meaning where that value actually is in memory. You don't know where it is. It's not really important to know where it is right now. You just know it points to x. And so then, if you ever wanted to get to that, you would simply dereference it, and then you would have that value. All of this is very dangerous. All of this is some of the worst errors that people get in C++ because screwing around with memory at runtime is not safe. It's very dangerous, and you almost never get a real error from it because the processor is just going to kill your program because it thinks maybe you did something bad, maybe you were trying to be malicious, and I'm just going to kill you now. But I think this is actually most important to go over because this is how C++ does arrays. So an array in C++ is actually created, if it's dynamic, with a pointer to just some structure out in memory. This pointer does not point to the array. It points to the first element in the array, which means that if you want to delete it, which you must, because otherwise you have what's called a memory leak, and you're going to have a bad time. I mean, and this is the reason I don't really want to go over pointers too much, is because every C++ program essentially has had memory leaks. Chrome, memory leaks. Firefox, memory leaks. Big thing. Oracle DB, tons of memory leaks. Oh my god. So these are the kinds of things that we don't do, and this is why Java was invented. This is actually one of the primary reasons Java was invented, because pointers exist. So we're done with pointers. And now to get on to, I think, what is the most fundamental part of C++ that defined an enormous amount of languages to come, which is classes. So we've created a class here. That class is called dog. That dog has a couple of properties. So that dog has a name, it's a string. That dog has a rating. And we know that that dog is a good boy. Why do we know that dog's a good boy? Because we've actually defined a default parameter value. So you can actually have in C++ default values for all of your properties in case that you don't want to initialize them, you forget to, things like that, and you want something there. You have what then is a constructor. So constructor here, it just has the name of the class and some things that you can pass in. Notice that all of these actually have default values, so you can pass nothing in, and it would still create a class and be all fine. And then we start assigning things. And then finally, we have a function. So this function is actually called a method because it's inside of the class. The class has a reference to this method, and it can be called by instances of that class. So then, we'll take a look at what happens when you want to call that class. So we create a dog, and that's just, it's exactly like a function call. Like we notice we're calling it, there's nothing there. And so then we can have that dog bark, or in this case, bork. And that will, yeah.
So something that I noticed is when we use the dot versus the arrow.
Okay, so the dot versus the arrow is interesting. It's actually the one thing that I didn't include. It's because when you use classes in C++, you're actually dealing with references to memory. So what that arrow hides is that actually you're dereferencing a pointer and then accessing what's at that pointer. You actually could use the dot operator, which is what gets you a property, but you have to dereference the pointer first. This does it all in one call. Now, if you're doing something like a structure, which only holds data, doesn't hold memory, then you could use a dot, because at that point you're dealing with a static instance of it, and you don't have to dereference it the same way if you've created on the stack, which you probably have. So that's kind of what the difference is. This is some nice sugar on top. If you're doing things in C, you don't have this. Have fun dereferencing your pointers manually and then using the dot operator. It's not a great time. So going to using these classes. So we've actually declared this class in a separate file here, and we can just include it. So the funny part is that C++ manages classes a lot in the same way that JavaScript originally managed things, by essentially just squeezing everything together into one file. for lack of a better term. So it takes all your header files, pulls them all together, and then your program runs off of that. It just looks around for the things that it needs, and it links everything together. Then we've got another main function. Create a dog, dog barks. That's it. Very simple. Next is inheritance, and this is a little bit longer because a lot of this stuff is going to go real quick once we start to see all these other languages and how similar they all are. We're going to have a dog. This time it's an own dog that inherits from another class. Yeah?
In the previous example, why did the destructor have a virtual keyword?
Ah, very good. Okay. So, let's go back. Okay, so we see that this tilde means that it's a destructor. What that means is when we destroy the instance of a class, this gets called. Nothing's here because we don't really need anything in it. We aren't doing anything that would require it. But the reason it's virtual is so it can be overridden by the base class, or by any child classes. So if you inherit from this, which we'll get to, if you don't make it a virtual function, you can never call this destructor. It will be hidden at compile time, and you'll just never be able to call it, which can lead to, again, memory leaks. Kind of a theme here, where if you screw something up in C++, you get memory leaks. So then, once we're finally onto a new dog, so this dog has an owner, it's called an own dog. We've created this, a owner here, and it's got its own constructor. Now notice that we've got all these parameters in here that aren't in properties of this class. So where are they? Well, they're in the dog. And then, when we have this constructor, notice there's a colon here, we then call the parent constructor, dog, with those arguments that were passed into us. So we can then just hand everything off to the parent class and say, we don't need to worry about any of the stuff that it did, we just need to care about this. But sometimes you want to override things. Sometimes you want to do things differently than what your parent class did. In that case, you can overwrite it by literally just declaring something that overrides it. It can have the same name and it'll just be hidden, and you'll use this one. So we're just going to do something a little more complicated here. And notice that dog here has all these properties that we were talking about before. And finally, we just create the same way and call it the exact same way. It's really kind of simple when you think about it. There's complexity hidden there, but the whole idea is that we have a parent class that then a child class uses for things. And it gets everything the parent class did for free, and then can do its own things on top of that. So now we're going to move on to templating and generics, which is by far, when I think of things that are the hardest thing in C++, that's number one, templating and generics. Templating is a tentpole of C++. It's very powerful, but also very complex. It allows you to write code that works with multiple types. What I mean by multiple types is, in this case, notice how we have something defined called template with class T, and we have a function called org 3 times. So notice that we're just defining something as T. What's T? Well, we don't know. We don't know what T is. But we're going to go in a for loop, and we're going to print whatever we get back from this org function here. Okay, interesting. Next, we're going to create two dogs. One that's a dog, one's a dog. So these are different types, and we're going to pass the instance of each to this function. Now, C++ will figure out at compile time whether each of these has this function. Since it knows that it does, we then allow it to call it. If it didn't have that, you would get a compile time error. It would probably not look that pretty. Most errors in C++ don't, especially templates. But you would get an error regardless. You aren't allowed to just do whatever you want with these. These aren't just like any type that you can just screw around with. Not how it works. Which is part of the point of C++. You trade a lot of your compile time. C++ has a very long compile time for very fast times to run things. So this will actually, if I remember how C++ compiles, this will actually create two functions, one for the dog class, one for the own dog class, and it'll call both, one for each class. So Generics is nice because you write one thing once and then it runs for 2 types, or in the case of like the standard library where you're creating like arrays and stuff, every type. It's very nice. And so that's C++. That's the longest one by far. These are going to fly by now that we've kind of understood how these work. So the next one is Go. This is Go's new logo, but you probably more recognize the older one, which is the Gopher, the Go Gopher. So Go was created in 2009 at Google by Robert Grissinier, Rob Pike, and Ken Thompson. So some of those names you might have a good idea of. Rob Pike was one of the inventors of Unix, as an example. So there's some serious pedigree here. So what is Go for? What is Go for? Go exists to increase productivity. Originally at Google, but not for everyone. Go increases productivity with large code bases that have network systems that have a high capacity for parallelism. So running things on multiple cores. That is the point of Go. Distributing a workload across a ton of network systems that all have multiple cores. But we want to do that while preserving type safety and speed from C++, readability, and readability from Python. So Go is meant to be very fast, very usable, and very readable. Those are its primary 3 things, and so that gets into a lot of the limitations, but also strengths of it. And above all, and this is an actual quote, Ken Thompson said, "The 3 of us got together and decided that we hated C++ and then so wrote this language." That's it. This is the real reason they wrote this language. They hated C++ that much. So it's a good sequel. And then as a quick kind of note, a lot of the examples I'm going over here have been adapted from stuff from gobyexample.com. If you want to learn Go, this is a fantastic site to start on. It's got really good, very simple, distilled concepts for everything in the language, and I think there's only like 30 things, so it's very nice to use. So we're going to start off with syntax and paradigms. So this is a Go program. It's actually probably about a third of the length it would take to write an equivalent C++ program. So we define a package. That package is main. That tells Go that this is the package to run when we start up. We've got a main function, just like in C++. And now we're going to create a list. It's actually called slice in Go, but we're going to call it a list. This list is of a bunch of strings. And notice this little kind of weird colon with an equal sign. That is variable initialization in Go. It's the only language that's really widely used that does it this way. Just kind of learn that's how it works, and you'll get it. It took me about a day to really start not writing var. But yeah, so then we're just going to create a simple counter, and then we're going to run through the array. So this looks kind of like what you do in Python, kind of like what you do in like a Java, but it's a little bit different. Range is essentially what it tells you to do when you're running through the array. We then get each of the strings in the array and the index of it in the array. We're going to then print that we're reading an element, and we're going to add that to a number that we've created earlier. And then finally, we're just going to print this many characters in the array. So relatively simple, very readable, very easy to understand, and there's really not a whole lot more here than there needs to be. There isn't var, there isn't pretty much any